The world of embedded systems, reliable communication is the backbone of every successful project. Whether you're working with UART, I2C, or SPI, each protocol brings its own set of challenges. Overlooking even a minor detail can lead to frustrating bugs, data loss, or even hardware damage. This video dives into the most common pitfalls engineers face when designing or troubleshooting embedded communication links. We'll explore real-world issues like voltage mismatches, signal integrity problems, and bus contention, and provide practical strategies to avoid them. By understanding these core challenges, you'll be better equipped to design robust, error-free systems. Let's start by looking at why these protocols are so widely used and what makes their troubleshooting both essential and tricky. UART is often chosen for its simplicity, but that very simplicity can mask critical design oversights. One of the most frequent mistakes is swapping TX and RX lines, which happens when engineers assume pinouts without checking datasheets. Voltage level mismatches are another major concern. Connecting RS-232 directly to modern MCUs can cause permanent damage. Ground loops and common mode issues, especially in systems with long cables or different power supplies, can degrade signals or even destroy components. Level shifting between devices with different logic levels is essential, and improper implementation leads to unreliable communication. Even cable length plays a role. Standard UART signals degrade quickly over distance, so using line drivers or minimizing cable runs is crucial. These are just a few of the many UART-specific issues that can derail a project if not addressed early. I2C is prized for its two-wire simplicity and multi-device support, but it brings its own set of headaches. Pull-up resistor selection is critical. Too large and signals rise too slowly, too small and you waste power or exceed device limits. Voltage mismatches between master and slave devices require careful level translation to prevent communication errors or hardware damage. Open drain configuration mistakes can cause bus contention, while clock synchronization issues in multi-master systems lead to data corruption. Even environmental factors like temperature can shift timing parameters, causing failures in harsh conditions. Address conflicts, especially with multiple identical devices, are another common source of trouble. By understanding these electrical and protocol level hazards, you can design I2C buses that are both robust and scalable. SPI offers high-speed full duplex communication, but its flexibility can be a double-edged sword. Clock polarity CPOL and phase CPHA mismatches between master and slave are a classic source of failed data transfers. Signal integrity becomes a major concern at higher speeds, especially with quad or octal SPI modes. Crosstalk skew and reflections can all corrupt data. Proper chip select CS handling is vital. Sharing CS lines or misconfiguring their timing leads to device conflicts and unreliable communication. Voltage level mismatches, long PCB traces, and improper termination further complicate high-speed designs. Unlike I2C, SPI doesn't natively support multi-master setups, so arbitration and bus management must be handled externally. By paying close attention to these details, you can harness SPI's speed without falling victim to its pitfalls. Mastering UART, I2C, and SPI protocols means more than just connecting wires and setting baud rates. It requires a deep understanding of electrical characteristics, timing requirements, and protocol-specific quirks. By proactively addressing issues like voltage mismatches, signal integrity, buffer management, and bus contention, you can prevent costly debugging sessions and ensure your systems work reliably in the field. Always consult datasheets, use proper test equipment, and validate your designs under real-world conditions. With careful planning and attention to detail, you'll be able to build embedded systems that communicate flawlessly, even in the most demanding environments.